Friends, good morning. So today we are going to start with an arithmetic series. What is an arithmetic series? Let us see. So on the top I've written an arithmetic sequence. I hope by now you know what an arithmetic sequence is. An arithmetic sequence is that having a common difference. So what is the common difference? It is the number obtained by subtracting a term by its succeeding term. So we have 4 minus 1 is 3, 7 minus 4 is 3, 10 minus 7 is 3. Since the difference is common, this is the arithmetic sequence. A series is a sum of the terms of the sequence. So this, adding them 1 plus 4 plus 7 plus 10 gives us an arithmetic series. Yes. So how do we write the formula of the series? The formula of the series will be written as Sn equal to term 1 or A1 plus A2 plus A3 up to AN. Now we have learned two kinds of sequences, finite and infinite. We have learned two kinds of sequences, finite and infinite. But here we will only find the sum of a finite sequence. Right now we will not find the term of an infinite sequence, we will find the sum of a finite sequence. So n I have written here. I can find the sum of the first three terms. So S3 will be A1 plus A2 plus A3. If I have S5, S5 will be A1 plus A2 plus A3 plus A4 plus A5. Certain the general term of a series here, Sn equal to A1 plus A2 plus A3 plus A4 up to An. Now we'll try to derive the formula. So let us say, for the sake of simplicity, we will only take the first, how many terms? Let us take 7 terms of the sequence. Okay, so to find the sum of the first 7 terms, S7, I have to add 1 plus 4 plus 7 plus 10 plus 13 plus 16 plus 19. Okay, so I have to add the first terms of this sequence. Now you may observe that whether I add the sequence in the growing manner or the reverse sequence, the sum should remain the same. So S7 is also given by 19 plus 16 plus 13 plus 10 plus 7 plus 4 plus 1. So either way the sum will be the same because of the commutative property. A plus B equal to B plus A. Okay? Okay. So now we'll add them. S7 plus S7 gives us twice the S7, 2 times. And we have 19 plus 1 is 20. 16 plus 4 is 20. So we'll get the total 20. And how many times do you have the total 20? You have the total 20 7 times. So it's 7 times 20. And so we'll have the sum of the series is 7 by 2, 20 times. So the sum of the series is 70. So you see again what I have done. I wanted to find out the sum of the first 7 terms of this sequence. So I added them once. Then I reversed the sequence. Adding the sequence same times give me twice the sum of the sequence, and you can see the total with the reverse term remains the same. So I got twice this equal to 7 times. Why 7? Because there were 7 terms, so it is 7 times 20, and we have this formula. Now try to use this formula. We have to derive the formula in terms of n and a and d. So now let us derive that formula. So what you can observe now, I have written the general terms of a sequence to find the sum. Now in an arithmetic sequence, how do we write the terms? The first term is a, the second term is a plus d, the third term is a plus 2d, and the nth term is a plus n minus 1d. Writing the sequence in reverse, we have a plus n minus 1d. Now how do you come forward? You subtract this term, you subtract d from this term. So subtracting d from this term, we have n minus 1 d minus d. That is n minus 1 minus 1. Are you following what I am saying? Subtracting d from this term will be a plus n minus 1 d minus d. So we have a, taking out common, n minus 1 minus 1 d, which gives us a plus n minus 2 d. So the previous term is a plus n minus 2d. Similarly, the previous term will be a plus n minus 3d, and we go in a decreasing order till we reach the a. Now, what will we do? What we did before. We will add up these sums. So we get 2Sn. Now what is a plus a? 2a plus n minus 1d. Again, add a plus d to this. So let us see what will we get when we add. Sorry, I'll do it separately. I've got a plus d. To that I have to add this term. So I'll write a, open the bracket, nd minus 2d. nd minus 2d. So I have a plus a, 2a plus nd. And what is minus 2 plus 1? Is minus d. So I have 2a plus n minus 1d. Like in the previous sum, we had got the total 20. So here also we are getting the same term, 2a plus n minus 1d plus 2a plus n minus 1d up to the n term. You add 2a plus n minus 1d. Now, how many times did you get this 2a plus n minus 1d? In the previous example, we had 7 terms, so we got the sum 27 times. Here we have got n terms, so this will be n times. So it becomes 2Sn equal to n into bracket 2a plus n minus 1d. And simplifying, we have Sn equal to n by 2 bracket 2a plus n minus 1d. This is the formula. This is the formula to find the sum of n terms of an arithmetic sequence. This is the formula. Remember this. Sn equal to n by 2, 2a plus n minus 1d. So I hope you have followed how we derive this formula. Once again, when we have an arithmetic sequence, we usually write the sequence in the growing order as it is given. To find the sum, to derive the formula, we write the same sequence in the reverse order. And when you write the sequence in the reverse order and you add them, you get the same term over and over again. And how many times do you get the sum? N times. So we divide, so we put the n as multiplication and the term, and dividing we get this formula. So this is the formula we do, and we have got Sn equal to n by 2, 2a plus n minus 1d. Okay. Now there's one more thing we can do. We can also write Sn equal to n by 2, and this 2a can be written as a plus a. So a plus a is 2a, and then I write this plus n minus 1d. So Sn equal to n by 2 a plus. Now what is a plus n minus 1d? It is the nth term or the last term of the sequence. So I can also write this as L, where L is what? L is the last term of the sequence given by a plus n minus 1d. So this is also one more formula to find out the sum of n terms of an arithmetic sequence. So here we have derived two formula today to find the sums of n terms of an arithmetic sequence. Okay, now we continue. The next step we have is to find the sum of n natural numbers. Okay, so which are the natural numbers? You know, the natural numbers are 1, 2, 3, 4, yes. These are the natural numbers in which the common difference is 1. The first term is 1 and the common difference is also 1. Now we do the same step. Reverse the sequence. N minus 1, n minus 2 till I reach 2 and I reach 1. When I sum them up, I get 2Sn equal to n plus 1, n minus 1 plus 2, is also n plus 1. N minus 2 plus 3 is also n plus 1. So we get n plus 1. How many times? N times. So 2Sn equal to n into n plus 1. So Sn is equal to n into n plus 1 upon 2. This is the formula only applicable when our arithmetic sequence is a series of natural numbers whose first term is a and common difference is a. Now we have a very interesting story behind this formula. Carl Friedrich Gauss, who is called the Prince of Mathematics, was a very bright student and used to ask questions to his teacher. To keep him busy, his teacher told him to find the sum of the first 100 natural numbers. Yes, he was told to find the sum of first 100 natural numbers. Means he had to add 1 plus 2 plus 3 plus 4 up to 100. The teacher thought that will keep him busy, but he used this trick. A very bright child, he wrote the series 1 to 100, 100 to 1. So what happened when he added them? You can guess. He got, adding them in reverse, he got twice the sum is. What is 100 plus 1? 101 plus 101 up to 100 terms. So Sn was what? These are 100 terms. So 100 into 101 upon 2. And he immediately gave the answer 5050. So Carl Friedrich Gauss, the bright child, derived this formula in a very short time and gave the answer immediately. So this is a very interesting story related to this formula, to find the sum of the first n natural numbers. So he was given the task to find the sum of the first 100 natural numbers, and he did it instantly using this trick. So now you can also use this trick to find out the sum of natural numbers till you want. For example, if you want the sum of the first 20 natural numbers, then you put n equal to 20. So you get 20 into 20 plus 1, 21 upon 2. So it's 20 into 21 upon 2. So what do you get? You can check out 20 into 21 upon 2. So 210 is your answer. So this is a very quick formula, but remember again, this formula is only applicable when the arithmetic sequence is a sequence of natural numbers. So today we have derived the formula to find the arithmetic series or the sum of an arithmetic sequence. Again, what is the formula? Sn equal to n by 2 bracket 2a plus n minus 1 d, where n is the number of terms, a is again the first term of the sequence, and d is the common difference. Now we'll try out a few sums, one or two sums, so you will get a very clear idea. On the board now, find the sum of first 20 terms of AP 1, 4, 7, 10. So let us see. What is the first term here? A is equal to 1. And what is the common difference? D is equal to 3. What is the formula? Sn equal to n by 2, 2a plus n minus 1 d. So let us put the terms. We have to find the first 20 terms. So n is equal to 20. So 20 divided by 2. A is 1. So 2 ones are 2 we have. Plus n is 20. So 20 minus 1 is 19 and d is 3. So we have 2 divided by 20 is 10. 2 plus 20 minus 1 is 19. 19 threes are 57. So we have 10. 2 plus 57 is 59. And the answer is 590. We have solved this example. And I hope you can see that finding the sum of the first 20 terms of this AP. So we have used this formula of the sum of an arithmetic sequence. Okay. So now let us move on to the next sum. So the sum is, find the sum of first 30 terms of an AP whose second term is 2 and seventh term is 22. So this sum is similar to the sums we have done before of arithmetic sequence. How is to first find the A and the D. So here the n is given, n is 30, because you have to find the first 30 terms. So n is 30. but the A and the D is not given. So we are supposed to find the A and the D. Okay. So the second term is 2. Can be written as 2 equal to A plus 1D or A plus D. The seventh term is 22. So 22 is A plus 6D. Yes. Now subtracting the 2, we have 2 minus 22 is minus 20 is equal to minus 5D. So D is equal to minus 20 upon minus 5, which gives us D equal to 4. Now 2 is equal to A plus D. So 2 is equal to A plus 4. So A is equal to minus 2. So using the previous formula, we have found out D is equal to 4 and A is equal to minus 2. So the sum of the 30 terms is 30 upon 2, that is n upon 2, 2A minus 2 plus n minus 1. So 30 minus 1 is 29D. D is 4. So we have 30 by 2, that is 15, minus 4, and 29 fours are we have, for the 36 carry 1, 4 2s are 8, 36, 9, 4 2s are 8, 8 and 3, 11. So we have 15 into 112, and the answer should be answer is 1680. So 1680 is the sum of the first 30 terms of the AP, whose second term is 2 and seventh term is 22. Okay, this is a slightly different sum. So try to understand this sum in detail. The sum of first n terms of any AP is given as Sn equal to 3n square minus 4n. We have to determine the AP and the 12th term. Okay, as you can see now, we are given the general formula of the sum of the series this time. Yes, see carefully, we are given Sn is equal to 3n square minus 4n. This is the formula of the general term of the series, not the sequence, the series, that is the sum of the sequences. So, if I put n equal to 1, I get S1. S1 is 3n square minus 4 into 1, that is 3, 1 square is 1, 1 3s are 3, 3 minus 4 is minus 1. Now what is the meaning of the term S1 equal to minus 1? Now in a series with only one term, when there is only one term, the sum of one term is the term itself. I hope you are following. I hope you are following this. We are given Sn equal to 3n square minus 4n. So when I put Sn equal to 1, I get S1 equal to 3 into 1 square minus this, so minus 1. Now S1 is the sum of the first term. S1 means the sum of the term, but there is only one term. So one term has got no sum. So you can say the first term minus 1 S1 is also A1, the first term. I hope you follow this. When there is only one term of a sequence, only one term, the sum and the term is one and the same. For example, in our sequence 1, 4, 7, 10, if I got only one term 1, then that is the first term, and the sum, that is also 1, because there is no other term to add. So when we get S1, we also get the first term. Now S2 is the sum of two terms. We put n equal to 2. So what do we get? 2 square is 4, 4 3s are 12, 4 2s are 8. So 12 minus 8 is 4. Now S2 means sum of two terms. S2 is the sum of two terms. Which are the two terms? The first term and the second term. Yes, the sum of the first term and the second term should give us S2. But we don't know the second term. We know the sum of two terms. So we know S2 is 4. We know the first term, A1 is -1, gives us A2. So we have A2 equal to -1 goes on this side, becomes 1 plus 4 equal to 5. So I hope you have followed. We have derived the terms of the sequence now. The S1 is also the first term, that is -1. The sum of two terms is 4, but the second term is 5. So I have got the sequence now. I'll write as -1, then I'll have 5. I hope you have followed. Now how do we find the D? The D is second term minus the first term. So second term we have is 5 and the first term I have -1. So 5 minus -1 is 5 plus 1 is 6. So we have D equal to 6. So we get the AP as -1 plus 6, that is 5, plus 6, that is 11, plus 6, that is 70. So this is the AP which we wanted. So the AP we wanted was this. Please be very careful and note it down. We were given the general formula not for the term AN but for the sum SN. This general formula is not for the term, it is for the sum. So putting n equal to 1, I get S1, the sum of the first term. But first term is only the same term because there is nothing to add. So the first term or the first sum is the same, -1. Putting n equal to 2, we get the sum of two terms. We got 4. But sum of two terms, so S2 is sum of two terms, A1 plus A2. We knew A1 from the previous formula, from the previous equation. Putting the value, we got A2 equal to 5. So D is equal to A2 minus A1. So 5 minus -1, that is 6. So this sequence has A1 equal to -1 and common difference D is equal to 5, as you can see. So this is the sequence that we want. Now to find the 12th term is simple. A12 equal to A plus n minus 1 D. Yes, so instead of n I'll put, let me write it again. A is -1, 12 minus 1, 11, 11 into 5. So -1 plus 11 5s are 55. So we have 54. The 12th term of the sequence is 54. So this is a slightly different type of sum and seen to the formulae. Again, we are given the general formula of the sum of the sequence, the sum and not the term. We are not given AN, we are given SN. So what we do, we first find out S1, also the first term A1, we find the S2, that is sum of two terms. From this sum of two terms, we subtract the first term, so we get the second term. And then subtracting the first term from the second term gives us the difference D. So we find out the first term, we find out the common difference D, and then we can solve the remaining sum. So I hope you have understood this sum very carefully. Go through it once or twice and understand it thoroughly. Then the other sums will be very easy. Is find the sum of all odd integers between 2 and 100. I hope you know what are odd integers. So if we begin, then the first odd integer after 2 is 3. Next comes 5 and 7. And we continue, then the last term is 99 because that is the odd number before 100. But now we have to find the sum of these integers. Okay, we know what is A. A is 3. We know what is D. D is 5 minus 3, that is 2. And the formula is Sn equal to n by 2, 2a plus n minus 1 D. Now what we don't know here is the n. Which term is 99? So we'll have to go where we did previously, finding which term is 99. So what will we do for that? For that we'll use the formula an equal to a plus n minus 1 D. So we know the term is 99, a is 3 and D is 2. So 99 minus 3 gives us 96. 96 is n minus 1 into 2. Bringing the 2 in division, we have 48 equal to n minus 1 implies n equal to 48 plus 1. So n is 49. So 99 is the 49 term, and now we have found out n equal to 49. So replacing in the formula, 49 upon 2, 2a, a is 3, so 2 3s are 6, plus 49 minus 1 is 48, and d is 2. D is 2. So we have 49 upon 2, 6, 48 2s are 96. That gives us 49 upon 2, 96 plus 6 is 102. 2 1s are, 2 51s are. So 49 into 51 should give us the answer. So what is 49 into 51? Two, 4, 9, 9. So the sum of all the odd integers between 2 and 100, yes, we should get it 2499. So I hope that this type of sums are clear to you. Now you can try a few sums on your own. When we will meet next time, we will do more sums. In case you have got any doubts, you can always contact me on the number 9624 884360.